Light itself, the very thing which defines how we see, is made of particles. We don't often think about the implications of this. For instance, how would we see an electron? Think about it. If light is made of particles, then the only way to see another particle like an electron is if a photon hits the electron. In particular, let us imagine an experiment to measure the position of the electron. The electron is located somewhere, and the only way to find out where is to observe it. And to do that, the electron must interact with another particle. The consequence of this is that the observation can interfere with the actual measurement. The consequence of all this is that there's a fundamental uncertainty introduced seemingly by the act of measurement. In order to measure the position of an electron, we must move the electron by some amount, and we can never know by how much. Think about it. You can only know something if you observe or measure it. If you have a closed box, then the only way to find out what's inside the box is to look. This is as true in quantum physics as it is in classical physics. After observing it, and say for instance you see an apple, you know now that there's an apple inside the box, and even after closing it you can still be pretty certain it's there. But the same is not true for particles. If you open the box, in order to look at the electron, we must influence its position. Thus, after we observe it, we are no longer certain of its position. So what does this all mean? Observing something is not simply the process of gaining information. Observation in quantum mechanics is just another interaction between particles. We see something when a particle of light, a photon, collides with the thing and reflects into our eyes. For a regular object like an apple, this makes no difference, as tiny photons cannot significantly influence its position. However, an electron is very tiny, so when a photon collides into it, the electron must move. So simply looking at an electron changes its position. If we know where the electron is now, then we need not be able to predict where the electron might go. This is interesting because in order to find out where the particle will be at a certain time, all we need to know is how fast the particle is moving. We call this the speed or velocity. The faster the particle is, the further away it will move. Quantum mechanics is telling us, therefore, that if we know where the particle is, then we cannot know how fast the particle is moving. The converse of this is also true. If you find the exact velocity of the particle, then it is not possible to know where the particle is. This surprising fact is known as the uncertainty principle, and it was first discovered in 1927 by Werner Heisenberg. This principle is the heart of quantum mechanics. Many interesting phenomena that we observe with particles come from this fact. Heisenberg showed that uncertainty is a fundamental fact of nature that cannot be avoided. It applies not only to position and velocity, but also to many other interesting quantities. For example, energy and time. The principle is a truly remarkable one.